So let me quickly go through the start presenting. So this is deepC. Um, what is deepC? deepC is a deep learning compiler and inference framework that you can perform deep learning models and use those models inside tiny devices like Raspberry Pi, Arduino, Node MCU, and other embedded devices. So as a structure, deepC uses ONNX, Open Neural Network Exchange, as front end, which enables it to convert any other models to ONNX and then perform our graph optimizations and other things on top of that. So we can take on any kind of framework models from frameworks like TensorFlow, PyTorch, Keras, etc., which can be converted into ONNX. And in the backend, deepC uses LLVM compiler that helps it to do ahead of time compilation so that the models that becomes executable are highly optimized and they are well established in the least resource enabled devices. deepC also comes with a Python interface if you are curious. So you can perform NumPy like additions and other stuffs using our deepC framework too. And it has the NumPy compatibility. We will be coming to that part later. Uh, let's go through the design. So on the first step, we can see we have the ONNX models. Deep learning models from different kinds of frameworks will be converted to ONNX models. Currently, we are supporting TensorFlow, Keras, and PyTorch natively. For other models, you need to first convert it to ONNX so that our deepC compiler would be able to compile those models. Then we are passing those models to our deepC operators, which are implemented with C++ for performance in the backend. We are doing graph optimizations after that for our memory optimizations. Then in the backend, as I told you earlier, we are using LLVM toolchain, which helps produce optimized executables for those small devices, embedded devices, and we are currently supporting x86, ARM, RISC-V, etc. Those kind of CPU architectures. So moving on, so let's come to the features of deepC. So deepC supports operator fusion. So what it does is, if you have a loosely coupled layer that has two different operators, it helps you like in backend, it automatically fuses those two operators into one and loosely binds it into the whole network so that your whole model behaves like runs faster. Then we're coming to quantization. It is a popular technique which is used by many frameworks, and it is a feature of C++. And we are using C++ template types so that we can convert any mixed precision data types while compilation, so that our code base becomes stays light, and we have lower power consumption and lower memory bandwidth. Let's continue with the feature section. We have the memory layout is constrained by eigen C++ library, which is highly optimized with improved tensorization, reduced memory accesses, and cache misses, and those features. So as we are using the popular eigen library, we can say that our tensor class is quite optimized. Scalability, we are using Swig as a binding between Python and C++, so that in the back end you can enjoy the performance, while in the front end you can use the Python for quick testing and you can use it for wider usage. So another thing is wide support. So we will be supporting cross compilation, so that you can compile those models in our server and push those models in those devices that in those tiny devices like Arduino Uno, Node MCU, etc. So we will be flashing binaries directly to those devices. This feature will be coming into cAInvas soon, so that you won't be needing to do anything. It will just do that automatically. Moving on, let's see how our deepC framework works. Um, First, we will be seeing the Python operations. This is the import function that import statement that imports our deepc.dnmc as a PC. So let's um, declare array of 1, 2, 3, 4, 5, 6. This is a two-dimensional array, and this will be by default of type float. And let's say we are declaring another tensor that will be 10, 20, 30, 40, 50, 60 as type int. This syntax is NumPy like, so you won't be having too much difficulty understanding this. So by operator overloading, we can directly add these two variables just like NumPy can. Moving on to broadcasting, you might already be familiar with this feature. So what it does is, if you have two different shaped tensor and you want to perform any operation in them, so we have the broadcasting support, like you are stating that A is true and B is an array of two-dimensional array. So if you are adding those two tensors, it will add 1 to each of the values in this B tensor. And you can also convert to different Python types. Like if you are this Y is a tensor of deepC, so you want to convert it to Python list or Python tuple. So you can do that by typing list, passing that Y to list or tuple function of Python. Moving on to the NumPy and matplotlib compatibility, which you will be using a lot. So let's declare variable array of um, uh, uh, 5 variables from NumPy, and convert it to we are converting it to deepC tensor by dc.array, and x.toList is a NumPy method which converts this to a Python list, and we are taking that list and converting it to a deepC array. Now this is the NumPy to deepC conversion. Moving on to deepC to NumPy. So we are declaring in the same way a deepC array of 5 variables, and we are converting that to NumPy with .NumPy. And plotting with matplotlib is the same as you will do with the NumPy. So it's the same thing. You are declaring one variable which is a sign of A. This is a 5 variable, and you are plotting this with matplotlib. So this is the framework that we have developed as a front end. Let's move into the back end, how you can compile those models from different frameworks to deepC. So this is the deepC compiler usage. We call it the deepCC. So this will let's compile a TensorFlow model. So we have a TensorFlow saved model. This is a directory path, guys. This is not the TensorFlow model file. So this directory, you have to pass this directory as an input to the deepCC command, and you have to mention the format of from which framework the model is coming from. Like if it is coming from TensorFlow, you have to mention it. And let's compile the keras models. This is the keras model with extension of H5. Then you are passing format keras. But you don't have to do that always, because we can see that this deepCC can see that it has an extension of H5. So it knows that it is a keras model. So even if you don't pass the format equals keras, it will automatically compile that for you. Like this command becomes this one. This is a simple command, just deepCC and your keras model. It will do automatically the ONNX conversion and compile that ONNX model to executable, all of that for you. This is pretty simple. This is for TensorFlow and keras models. Let's jump back into other models. So as PyTorch is backed by Microsoft and ONNX is the same too. So PyTorch has a native feature of ONNX export. So you can import torch.onnx and export your PyTorch model into an ONNX file. It is a native feature that PyTorch has. But if you are coming from any other popular frameworks like sklearn, Piano, Cafe, Cafe2, etc., you need to compile, you need to convert that model to ONNX first. Then you will be passing that ONNX model to our deepC, because deepC currently doesn't have support for those kind of model, but the feature will be coming soon. So if you are converting to an ONNX file from PyTorch or any other framework, you can pass that ONNX file to our deepC, and it will just compile that for you, and it will build an executable um, which you can flash into your small devices, embedded devices. So this is how our deepC compiler would look like. currently in the use cases, there are multiple steps that you need to go through. So I have already seen that people are doing first converting to Onyx, then compiling with Onyx compile. You don't have to do that for TensorFlow and Keras. At least you would be just doing a simple line of code. Don't worry, guys. I will be sharing this slides with you so that you can take a look at it later. And for PyTorch and any other models, you need to convert it to the Onyx like you were doing before. So that's how our deepC compiler works, and I hope you understood what it is like and how it is working. We are currently supported. You can only compile deep neural network models for now, but later you will have support for machine learning models. So these are the references, and that will be all for the deepC. So you might be catching some bugs, as I saw today that people were catching bugs while compiling. Two kinds of bugs there can be there. So this is our deepC repository page. So you will be, I hope it is visible. So this is the page where the deepC resides. So if you find any issue, you can pull it up in the issue section, and you can create a new issue, and we will be looking into that. If it's even an Onyx issue, you can pull it up and pass this issue to here. We will be confirming back to you, and if the bug is fixed or this is technically challenged problem, we will be looking into that. So that's all from deepC. I will be sharing you the deepC link and the slides after the lecture session. And if you have any questions, you can always ask us. We are here. And with that, that will be all from my side. Rohit, can you take it from here?
Thank you, Gunjan. So yeah, it's essentially what we have is a framework, library, and a compiler, which helps, which is actually focused on low form factor devices, and currently takes the outputs of the popular frameworks like TensorFlow, PyTorch, Keras, Cafe, and so on. Uh, in future, we would be enhancing that to take a subset of Python and convert that algorithm as a model on for some of these the small form factor devices like microcontrollers, Raspberry Pis, MCUs, MPUs, and so on. So that's the focus. Now, Inference Framework is much larger than what Gunjan has shown you today. Um, it's compatible to NumPy, and NumPy is compatible. So rest of the frameworks are compatible to NumPy. So in a way, it's kind of a similar framework that you should not see any difference. And you can code up machine learning algorithms like KNN or K-nearest neighbor or K-means and things like that. And yeah, those are not neural networks. Currently, we are taking only neural networks because most of these frameworks, they support uh, neural networks, and that's the majority of the use cases anyway. Um, so yeah, now now it's just a now it's up to your imagination and creativity as to where do you take this flow and what kind of components you cook up in your mind as an interesting project, as somebody to help out, or starting a new company, or something new that would help people in general. And so if you have some of those exciting projects that nobody has done before, we would love to help you out in making sure the flow is flushed and you are successful in creating the project that you would like to see to help out others. We can take questions, and I'm sure the rest of the um, channel and the support community would be active. If you don't have questions now, would like to ask that later. We can stop recording at this point, Xavier.